Thank you. Morning, everyone. My presentation today will be an introduction to decentralized data storage systems, essentially the advantages, disadvantages they have, and the types of storage systems available out there, and a bunch of other stuff, really. Let's go. Right. Now, I'm sure some of us know who these guys are, right? If not, this is the Pied Piper team, the very brilliant team that created the Pied Piper app, the platform which is a decentralized data storage system, which uses decentralized data storage. And I'm sure we all know they never faced any issues. Everything went correctly for them. Like it was all wild, right? All seasons, everything was perfect. I bring this up because they've created a decentralized data storage platform that relies on like decentralized data storage, obviously. So I guess the question remains then, what is decentralized data storage? A simple explanation is decentralized data storage is an alternative to traditional centralized storage systems. It's a method of storing and managing data across a distributed network of computers or nodes where no single entity has complete control over the entire system. It enables users to store, access, and share files in a distributed manner, helping to increase security, privacy, and scalability in data handling. This is in contrast to centralized storage, where data is stored on a single server or controlled by a single organization. So some use cases for decentralized data storage include the decentralized web, or Web3 as it's called, which heavily relies on decentralized storage for hosting websites, applications, and user data. Decentralized storage can also be used for content distribution. So platforms like IPFS are used to distribute large files across a network. Now, in a decentralized system, the data is split, encrypted, and distributed across multiple locations to ensure that no single point of failure exists. The process of how that typically works is as follows. When you upload a file to the network, well, first of all, you have to choose a network to upload a file to. And then when you upload a file to that network, the process called file hashing occurs, where the system generates a cryptographic hash of the file's contents. This hash acts as a unique identifier for the file. File hashing is an important step for content addressing in a decentralized system because you will use this hash later to refer to the file. To ensure privacy, many systems will encrypt the file before splitting it. This ensures that only the file owner or authorized users can access the file. The file then gets split into smaller blocks where each block is encrypted and stored across different nodes in the network. Each node stores a different part of the file. The decentralized system manages where and how the file is distributed across the network, often in a way that balances load and redundancy. To later retrieve the file that you stored, you can request it by using the cryptographic hash of that file. The decentralized network finds the node storing the file's blocks, reassembles it, decrypts the data, and sends it to the requesting user. Now, decentralized storage systems can be classified into different types based on the underlying technology that is used to distribute data in the network. For example, we have a peer-to-peer or P2P storage, which is a decentralized storage model that relies on collaborative efforts of interconnected nodes, or peers as they are called, to store and share data. In this network, each participant has the dual role of being both a storage provider and a consumer, collectively contributing to the creation of a decentralized storage ecosystem. We also have distributed cloud storage, which combines the benefits of cloud computing with decentralization. Unlike traditional cloud storage, where data is stored in a centralized server, distributed cloud storage disperses data across a network of nodes, ensuring redundancy and fault tolerance. Another example we have is blockchain-based storage. As a decentralized ledger that records transactions across a network of computers, blockchain ensures transparency, security, and immutability. Decentralized file systems like IPFS leverage blockchain principles to create a distributed and content addressable storage network. Wow, that's a mouthful. Jesus. All right. Now, for some examples of decentralized storage platforms, we have Filecoin, which is a network that uses blockchain technology and its native cryptocurrency to incentivize storage providers to store data, offering a secure and cost-effective alternative to traditional cloud storage. We have Storage and IPFS, the Interplanetary File System, which are decentralized storage solutions that provide secure and cost-effective data storage and data sharing. Airweave is another blockchain-like platform that focuses on permanent data storage. This functionality, called the permaweb, is an immutable environment for storing web pages and any other types of data. It is also a censorship-resistant platform, meaning no single entity has control over what can and cannot be stored on it. And then, as we all know, the world's best data storage platform, Pied Piper. It exists, it's real, I believe in it. Anyways, going forward, I'd like to look at the advantages that decentralized storage systems have over decentralized storage systems have over centralized storage systems. I'll start with the pros. Decentralized storage systems have an advantage when it comes to security and privacy. Since data is often encrypted, it's stored in multiple locations and there's no central party that controls the data, the risk of data breaches or malicious hacking is reduced. Decentralized systems are also fault tolerant. Since data is distributed across many nodes, the system is more reliant to failures. So even if some nodes go offline or experience issues, the data remains accessible from other nodes. And then decentralized storage systems are also harder to censor since there's no central authority controlling the data. This makes it more difficult for governments or corporations to remove or block content. Now, as we all know, with some advantages come some disadvantages of systems. So the cons that we have are as follows. They do have performance issues. Since data is stored across a distributed network of nodes, accessing or retrieving data can sometimes be slower compared to centralized systems, especially if nodes are spread out geographically. Data availability is also an issue. Ensuring data availability can be complex because nodes may go offline temporarily, and if data isn't sufficiently replicated or backed up, there could be risks of data loss. Another downfall of these systems is their lack of ease of use. So a certain level of technical knowledge is required to use these systems. Setting up, maintaining, or even understanding how decentralized storage systems work can be a barrier for many mainstream users who are accustomed to the simple nature of centralized systems. In conclusion, decentralized data storage is an innovative approach to managing and securing data, focusing on distributed data across a network of independent nodes rather than relying on centralized servers. It offers numerous benefits, but their challenges, unless overcome, can hinder them back from realizing their full potential. I would advise that we all step out of our comfort zones and attempt to learn what we can about them so that we can all be contributing members of an internet that is made for the people, by the people. Thank you.